Alrighty, the final section in this chapter is on power, and power is simply the amount of energy, or I'm sorry, the amount of work that I expend per second. Now I slipped and I said energy there, but if you remember, work and energy have the same unit, so you can really think about them in the same way almost. So if power is the amount of work per second, work is expressed in joules. Time I normally express in seconds, and so a joule per second is the same thing as a watt, named after the physicist that did a lot of work in this particular area. Okay, so I would like to submit to you that you can take this power formula, and since you know that work is the same thing as the force parallel that is exerted times the displacement, I can substitute that formula for work into this formula, and I may save myself a little bit of work in the long run by the number of calculations I actually have to do. So this is an equally valid equation for power, just like this one is. I just substituted the formula for work into this one in the same way. So then if I look at example 8.9, a woman pushes a rock 4.3 meters. So this is example 8.9. So delta X is going to be equal to 4.3 meters. She exerts 52 newtons of force. So I'm going to put that in, 54 newtons of force over 2.10 minutes. And then I'm asked what her average power output would be. Now, the first thing that you need to notice here is that my time has been given to me in minutes, but in order to calculate power in terms of watts, I need to have it in seconds. So the first thing I'm going to do is I'm going to go ahead and change this to seconds by using conversion factor 60 seconds in 1 minute. So then my minutes will cancel out, and that will give me a time equal to 126 seconds. I can keep 3 significant figures because you remember that this is an absolute conversion. There's exactly 60 seconds in a minute, so I can keep 3 significant figures there. So then to calculate power, if power is force times delta X over delta T, that's going to give me a force of 54 newtons. Delta X was 4.3 meters. Delta T was 126 seconds. So that when you crunch those numbers will give you a final answer of 1.8 watts. And I can only have 2 significant figures because my distance and my force both only had 2. So 1.8 watts for that. So that is power, and that concludes this module.